LeetCode question number 206, reverse linked list. This is easy question. Let's get into it. This question is one of a famous question of Google interview. So frequency is quite high. Actually, a few days ago, my friend got a Google phone interview, and then this is question of that Google interview. Okay, let's get into it. Reverse a single linked list. Let's check the example. This is a single linked list, and then we need to reverse, right? 5, 4, 3, 2, 1, no. And then there is the follower. A linked list can be reversed either iteratively or recursively. Could you implement both? Sure. Okay. Today I'm gonna implement the both way with the iteration and recursion. First, let's start with iteration. So current head is this one, right? So iteration, I would like to use the 3-pointer. So first is the previous, and then current, and then next. So in this case, first I will put is the none position, and then let's change this none because this is Python. So my strategy is I will change the pointer one by one. And then I'm gonna return the here. Then here 5, 4, 3, 2, 1 none is same as this one, right? So to do that, first I'm gonna position prep is here. This is prep, and then current is here, and then this is next. So first with the 3-pointer indicated each node. So first I will change current next is previous. So now this one. Before that, I will put current next is next. The reason is after we change the pointer, current cannot go to next. Does this make sense? That is reason. And then I will move from prep to current one by one like this. To do that, first I will move the prep to current position here, and then I will move current to next position here, and then I will calculate the current next here, and then I will do it again, and then change, and then move, and change, and move, and change, and move, and change. We're almost there here. So this is the X point. So at this time we just return flap, right? Okay, let's implement code. First the flap, go back. Now here, right? Now flap has none, right? And then current has the head. Head is this one, right? And then head next. Then the iteration current is null, and then first I will put current next to next for next iteration. So next is current next, and then I will change current next to prep like this. So current next is prep, and then Now I move to prepped current. So now prep is here, and then I will move next. I will move current to next. So current is next, and then next iteration I will do it again. Next is current, next is here. So change this one, and then do it going again to here, and last we return just the previous. Okay, let's check the code. Okay, looks good. Awesome. Oh, performance is not bad. At this time complexity is linear time with constant space because we do not use any data structure. And okay, now it's time to implement with recursion. Head is same as. In this time, I'm gonna use system stack because recursion provides the stack. So when you go in here, we will call the stack, and then now here, and then call stack here, call stack here, and call stack here until 5, because we need to return 5 value. So current next is null. I will return. That is the base case. So okay, let me implement the code. So first, if head next is null, I will return head. So I return. So first, if head null, we need to return null. So okay, let's edge case handling head, or then if head is null, we return null. If we go to the here, we return here. Does this make sense? To going to next step, I will do node is self dot reverse list and head next. So when the starting, this is invalid, and then this one skip, and this time we start here, right? And then this one is next is exist, or this is not null. So node is going to the head next. So next system stack start with here, next here, here to here, right? So when you here, node is must be 5 null, indicate null, right? Okay, let's change the Python way. So okay, now we get this one. So we needed to generate one by one, and then when this one is node, right? Node is here. Then after go back here, node is indicate here. At this time, head is which one? That's right, head is this one. This is head, right? Because we popping one system stack. So environment head indicate 4. So at this time, what we need to do is, first we will make the 5 4. To do that, I will move the current head next is head. So okay, I will do like this. Head next is head. That means this one is head, and then this one is head next, and then head next is head. Means 4 5. What is next? None? No. Next is 4. Because 4 indicate 5, 5 next indicate 4. so it will be circled. Does this make sense? So, and then next we needed to do to cut the circle, right? So now we need to 4 is we need to make 5 and 4, right? So we needed to cut here. To do that, I will head next is none, like this. Then every 4 node next turn into none, right? Does this make sense? Not only here also. Now we change it. 4 does not next does not indicate none, it indicates 4. So indicate 4, and then 4 next is none. Now we made this one. And then popping. So cut is head, next is none. And then popping, and then node is this one, and then now head is here. So we do it again. Popping start here, right? So in this time, head next. This next is 3, 4, and then head next is none. So 3, none. Right? So then now node 4 change it to 3. This one change it to 3, and then 3 is none. Same way, 2 also same. At that time, finally we do 2 none, and then when we are here, it is 1 none. Does this make sense? So we return which node. Okay. Okay, looks good. Time complexity, the going to here, it take n, and then popping also take n. So time complexity 2n is linear time, and then it use recursion, and the recursion use system stack. So linear time is linear space. Thank you.